On today's World Insight, basic sciences, the building blocks of scientific advances and of tech collaboration between top economies such as China and the US. How far can scientific cooperation go despite complicated geopolitics? Answers from today's special series, Brilliant Minds, as we pick the brains of Shing-Tung Yau and Nobel laureates in physics, Samuel C.C. Ting and Steven Chu.
Hello and welcome to World Insight with me, Tian Wei. And this is our special interview series, Brilliant Minds. They say the fewer the facts, the stronger the opinion. At a time when perception apparently changes reality even more than facts, it is time for scientists to speak out and share their thoughts. With the world's leading scientists gathering to promote collaboration and knowledge exchange, especially in the fields of mathematics, physics, and information science and engineering. It is really like a celebration of human wisdom. I had a series of interviews with these brilliant minds, and today let's meet a few of them. First, Professor Shing-Tung Yau, chairman of ICBS. He is a celebrated mathematician and the first Chinese recipient of the Fields Medal. How would you be able to support your fellow scientists? What do you think can fundamentally, once again, open up people's eyes and let them see the charm of basic science, not just as a competition tool?
The beauty and the truth of basic science that can provide of nature is the most important. When I see, say what Professor Ting has done in the experiment, seeing the charm clock, and what Professor David Gross did on the asymptotic freedom, these are really the truth of nature. And it exhibits such a beautiful connection between mathematics and the actual phenomena. Is fantastic and astonishing, I would say. And this attracts us that we want to pursue to understand them more. It takes a lot of work to achieve that, but once it's achieved that, it's such an astonishing beauty behind it. And this is a part that really attracts the Greek scientists to continue, even when it's hard time, when there's no money and all that. But science, develop good science does involve money, because without funding, we cannot train our younger generation. We cannot, we have a family to support also. All these are still very important. But supporting fundamental science takes very little money from the society, actually. But the reward is tremendous. And you're talking years and years, even 1,000 years reward. And electromagnetism, for example, when it was discovered, understanding in 19th century, it has been tremendous, important for the day-to-day life, as you know, electromagnetism and all that. So I think it's the beauty and it's our great desire to understand nature that really promotes our enthusiasm to understand basic science.
But people are concerned these days also because science is really taking off, basic science, but at the same time, geopolitics also has been changing. Latest tariff war, that's another aspect of these changes that we've been talking about. How do you, as a scientist, look at these things?
We have to open up no matter what. And basic science is always fundamental to...
When you say we, meaning China or meaning China, Congress or...
Well, the Congress is one of them, and the Congress is part of China, of course, is an important gateway for China to open up to the Western world and to see our friends from Europe, from America, which with the current situation, it could be difficult if we just send our students outside because we are being blockaded by American government and all that. But science should have no boundary. And all scientists knows that, and they know they can learn from us, and we of course learn a great deal from them, and this is a very important bridge. And we learn from each other. Without learning from each other, science would progress much slower. And especially for China, we cannot close up. We have closed up the gate for a few hundred years. That was a disaster for Chinese development in science. So we should insist to open up. I've been mentioning an interesting curiosity. Japan, of course, during the Second World War, has invaded many countries. But even during the war, some of the Japanese scientists are doing really great, important work. And they are not necessarily related to weapons. And some very fundamental work was performed, even during the war period. And they also try to learn from outside. So
there are independent thinking scientists.
Yeah, they are independent thinking. So science is a very attractive subject to many human beings. So we are attracted by its beauty, and the truth transcends war, transcends nations, and I believe this is very important.
Samuel C.C. Ting is a Nobel Prize winner in physics from MIT. This towering figure now leads an experiment on the International Space Station. It provides a precise study of the origins of cosmic rays and the existence of dark matter and antimatter. During a press conference, he told me he is fascinated by the fact that none of the research results so far he collected agrees with the current theories of the field, which means it may require the development of entirely new theories. You are leading a project on the International Space Station involving more than 16 countries. And you mentioned as well that some of the current theories could not explain or actually go exactly the opposite of some of the discoveries you have found recently. Can you explain which direction in your research is it going to as a result? And by the way, if I could just follow up on that, you are doing experiments in the outer space. How can you also be grounded on the Earth as well? Thank you.
Back in 1990, when the United States terminated the project of the world's largest accelerator, I've worked on electron accelerators, proton accelerators, all sorts of accelerators, and I was thinking about what's next. It suddenly occurred to me that the universe originated from the Big Bang, and before the explosion, the universe was a vacuum. After explosion, half of the matter is positive and the other half negative. So where is the part of the universe which is composed of antimatter? So you have to make a big magnet and bring it up to the space. Many people thought about it but didn't make it because a huge magnet will affect all flying objects, including spaceship and space station. So I figure out a way to solve the problem. But still many people thought my idea of put a huge magnet was impossible. I managed to gather a group of Nobel laureates to evaluate my experiment plan. They approved it. That cleared the way for my equipment to go to the space. The equipment was very heavy and the experiment was expensive. And when it began to circle the Earth, I had to work 7 days a week. Till now, the magnet has been in the space for 14 years, and it has received 250 billion cosmic ray data with very high energy. Analyzing these data, I found a lot of phenomena that are inconsistent with the current cosmic ray theory. It's almost like saying that rebellion brings out the truth. We've published a lot of articles. People take these articles very seriously, thinking that they are completely new, something that no one can imagine. I hope in another 100 years, more of these things can be explained.
That's Samuel C.C. Ting, and physicist and Nobel laureate. Next in the program, our special series Brilliant Minds, I will share my in-depth conversation with Steven Chu, Nobel laureate and former U.S. Energy Secretary, on China-U.S. scientific collaboration and the future of batteries and carbon capture technologies. Welcome back. This is World Insight and our special interview series, Brilliant Minds. I'm Tian Wei. This is in-depth conversations over the years I had with leading scientists from all over the world. Steven Chu is a professor of physics and the 1997 Nobel laureate in physics. He's a vocal advocate for more research in renewable energy and nuclear power, arguing that shifting away from fossil fuels is essential to combating climate change. After leaving the political office as U.S. Secretary of Energy, he continued his research in that field. Lately, he has been researching new batteries and carbon capture technologies. I had an in-depth interview with Professor Steven Chu. He warned that rising political tensions threaten vital supply chains and research cooperation essential for addressing global challenges such as climate change. Take a listen. Professor Chu, what a pleasure to see you in Beijing.
Oh, my pleasure also. Thank you.
Congratulations on the award.
Thank you. It was quite unexpected.
How do you think these cross-discipline interactions among scientists could mean to you?
What happens is if you're in one field, you learn a certain number of tools and methods. And then when you go to another field, you can mix and match and take a lot of things. So in doing science, in many respects, it's like being an expert chef. You have lots of ingredients, and how you choose to blend them and make them into a good dish is fun.
Both new batteries and the carbon capture technologies. Tell us more about the direction you're heading for and why do they matter?
Well, first, let me say, since I'm in China, that Chinese battery technology and the battery companies, notably CATL and others, become world leaders in batteries. And so it's a little bit humbling to see this. But nevertheless, it's trying to introduce, some radically new ideas to solve some problems of getting to higher energy density batteries. So right now, if you have a battery that's for electric vehicle, it has a certain amount of weight and a certain amount of size. If you can make the weight half as much, it could mean a lot for the cost, the range, everything else. Also, half the weight, a third the weight, it would have profound difference for aerial craft like drones. And it's a very big deal to have very lightweight batteries for drones.
So where are we?
I'm pursuing a direction that's long been recognized. It's to use, instead of having a conventional battery which puts lithium in with carbon, and then the next step is lithium with carbon and more silicon. And now but the best one is none of the silicon, none of the carbon, just pure metal anode. And then it has the highest energy density because all the atoms can be used for the battery, and it has a slightly higher voltage. So it's a very high energy density. The problem is when you charge at a sensible rate, there are these defects that form that called dendrites, and they go over and they short out the battery. So the object is to prevent these dendrites from forming. And there are many, many ways of doing this, and I'm just investigating one of the ways of making a barrier strong enough so that dendrites don't form but can be practical and inexpensive.
I hope some of the latest experiments you are doing with your frontier will be able to be widely tested in the market and also by the marketplace and also other stakeholders.
I hope so too, but it requires several things. First, we have to demonstrate that it really works. We had some preliminary evidence. Actually, started with some material we bought from China, then the Chinese supplier lost know-how on how to do this. And so they're trying to get it back. And so in the meantime, we're also trying to make our materials ourselves. And what I'm a little afraid of is the world politics will shut down this. Both the scientific collaboration, but even the material supply, which would be a shame. But one hopes. Very important, as you said, to really make better batteries, not only for electric vehicles, but it would be needed to transform the electricity supply and distribution system. And then finally, I'm trying to work on utility scale batteries that do not catch fire. And that usually means you have to work with a water-based system.
Right.
And so I'm trying to figure out a way to use water, but to prevent the water from getting to the electrodes. If you can do that, but the rest of it's water, then you can go to a higher voltage, because if you go above a certain voltage in water, you make hydrogen and oxygen. You don't want, and that's only 1.3 volts.
And the other thing is carbon capture, which is very exciting right now, despite of the setbacks in policies regarding actions against climate change. Tell me more about that, the carbon capture. Which direction, what is likely to be the outcome?
It's absolutely necessary because of the carbon emissions of the world, and there are certain areas that it would take several decades at least as a minimum. For example, the greenhouse gas emissions from agriculture due to fertilizer. Just fertilizer use. The fertilizer goes in the ground, now absorbed by the plant. It comes out as N2O, which is 300 times worse greenhouse gas than carbon dioxide, lasts 100 years. Methane's about 80 times worse, lasts maybe 10 years. But you cannot stop using fertilizer because we're 8 billion people going to 10, 11 billion people. And so how do you do this? Well, it's actually going to be probably a biological way. That is, you take microbes and you program them, change them, so that they can enter into symbiotic relationships with the plants. We already know this with soybeans and other, they can take the nitrogen and other nutrients in the soil and they can, quote, self-fertilize. So I'm beginning to work not on what we call synthetic biology part, but on the ability to get very complex genes into cells. So the carbon capture technology that we have today is fundamentally too expensive. When you look at areas which have carbon pricing, for example, the energy market in Europe, and there may be 100 euros per ton of carbon dioxide, it won't go to 200. So if it's 100, then you need to have a technology to capture carbon that would be less than that, so when people capture the carbon, that they have financial remuneration for that. They can, in fact, make a profit. Air capture right now, to capture carbon dioxide directly from the air, which is also necessary, maybe costs 400 or 500 euros a ton of carbon dioxide. So if you can get it to 100 or 50, it would be a very big deal. And so we might have stumbled on a way. It's too early to say, but it has caused a lot of generation.
If I understand right, when you quit the job as the Secretary of Energy, you said the reason why human beings ended the Stone Age is not because they were running out of stone, but rather they just move on to a very different stage.
Right.
And I really wonder about now. It's, some say, even comparable. Fossil fuels has been the reason of many of the problems that we are seeing. Right. Of course, there are clean energy that's making fossil fuel more viable, but still...
Less viable, maybe.
Less viable. But on the other hand, you see national policies are not necessarily progressing, but rather going backward, at least in some cases. Right. So you, as a scientist and an official who is so keen on this, what is your take?
There are reasons why a politician might do this, even if they knew better. It has to do with an incumbent industry. I mean, the world has benefited, as I said, from fossil fuels for hundreds of years. They're the incumbents. They have lots of embedded resources and investments, and quite powerful. And so they want to survive. But I think they also know that climate change is very real, and that fossil fuels is a huge part of that. You know, some people will say, that's not my problem. And so then they will try to influence politicians to back them. And they influence politicians in the US by giving them money for campaigns and things like that. In the end, no matter what a politician thinks, there is a reality. And the reality is the climate is changing. We believe it's mostly due to fossil fuel burning, and we have to change. So, having recognized this, I think China has taken a very long view and the proper view. It said, okay, if this is happening, then we have to try to lead in all those technologies that allow us to make a transition to carbon-free electricity, but not only that, to reform agriculture, to reform all these other things.
It's a whole ecosystem.
Right. And so if you look down at all the list of things, whether it's now, solar power is getting very inexpensive. Now it becomes the integration of solar power. Electric vehicles, I think within a decade or less, will become the dominant mode of transportation, the car of choice. But there's a problem, because then you need charging stations. And if you have many, many charging stations, then you have an electricity distribution problem. And so then batteries comes back, because you can imagine if you get a battery local to the charging station, you can buy electricity during the peak noontime, where it's nearly free because of solar, or at night, where there's less demand. And so you can buy electricity when it's free or nearly free, and you can sell it at a huge profit if you had a battery. So that's another application where you don't have to restructure the entire electrical distribution system if you had good batteries.
On the other hand, you also see China trying to connect the grids together with some of the latest technologies coming from renewable energy. Now it's already 20% about in the country. So it's a mega experiment, shall I put it that way, how it could work in a country like this.
Yes and no, because California, of course, it's not the smallest fraction of China, but California is now 70% non-fossil fuel electricity. There are countries in Europe that are, well, I discount Iceland and Norway because they have hydropower. But if you look at Germany, for example, and other countries, they're marching along trying to go 30, 40, 50, 60%. But in order to do that, they have to coordinate with many countries in Europe. Okay. Similarly, China has to coordinate with all the different provinces and sectors in China. You have great wind in the northeast, northwest. You have great hydro in the southwest. But you have a very complex grid system, and to coordinate that so you just don't throw away the electricity, which is being done already, not only in China, but in other places.
But now we see geopolitics as well as geoeconomic reasons. Sometimes even climate, clean energy is being used as a trade barrier from time to time. So as a scientist now, having that hat, how do you see other factors are complicating the process forward? And at the same time, how will those new technologies not being wasted, but really serve the people, as they say?
So let me start with trade barriers. So in general, you want to minimize trade barriers. You waste a lot of money trying to isolate yourself. It's not using, the capabilities of the world. Now, having said that, I could say there would be a reason to have some protection. For example, if you're a developing country and you want to protect your farmers, your indigenous farmers, if they have a crop failure for 1 or 2 years, they get wiped out. The food will come from somewhere. So you need a few things to protect the people in that country. But in general, it doesn't do much good. It's very destructive. This whole thing about tariffs, in my opinion, is largely destructive. And so one hopes that we get back to a previous world where there's a World Trade Organization, you settle these disputes in a knowledgeable way that benefits everybody to the greatest extent possible. Is very, very important. But now it's being used if the economy is not going well, and there may be a fraction of society that's not doing as well. So a politician comes along and said, well, the reason your life isn't getting better is because there are people to blame. History says you need an internal enemy and an external enemy. In the United States, the internal enemy, immigrants. External enemy, sadly, China. And so this is just a way of strong people who aspire to be autocrats do it this way.
All of these fields, actually, both China and the United States are very strong stakeholders and also contributors can be. Is the current situation of bilateral relations between these two countries satisfying to you, both as a scientist, as a former official, and as someone who happened to know both cultures a bit? At least much in the US culture, of course, also some Chinese culture through your families.
I think what is happening is a shame, but I firmly believe it's not to the people's in China and the people's in the United States advantage to have a political war, a Cold War, or warm war. None of this is good for either society.
You were a Nobel Prize winner. You've been into so many different fields. Now, how do you think, what is really driving our next stage? Some say, there are linguistic traps. We invented the concepts ourselves, and then we try to fill the world into that concept. Others say it's actually technologies that are really driving the changes of the world. There are also those who say, pioneers and real leading minds that are willing to sacrifice will be the key. What do you think?
I think there's a little bit of everything. But as a technical optimist, a scientist, I really believe that technology can, if used in the right way and used in society the right way, because science in itself is neither good nor bad. It's how does society actually use the science? And so there's a huge opportunity to use science to better people's lives. There's a huge opportunity to use science in diplomacy because scientists talk to each other, they trust each other. And this is one thing where this is a lesson that was amplified when I was in Washington, D.C., that the world works on personal trust. Like it or not, it works on personal trust. And if they trust you, they could listen to you. If they don't trust you, nothing is going to happen. How do you trust someone? Well, you have to be honest with them. You have to, and then after a while, even if they may not trust you, if they realize you're being open and honest, it would be good. So building trust is the most important thing in diplomacy, in national relationships, in personal relationships. It's all about trust.
Thank you so much, Professor.
You're
really
welcome.
Appreciated your time. That's Steven Chu, professor from Stanford University and the 1997 Nobel laureate, who also served in U.S. government as the Secretary of Energy. And that's all the time we have for today. If you'd like to know more, search World Insight or check out our YouTube channel. Follow us on X and Facebook. I'm Tian Wei. On behalf of the team, thanks for being with us, and I'll see you tomorrow. Bye for now.